Craving more action? Show your support. Like this video, subscribe to our channel, and flick on those notifications. Keep the thrill coming. Have you ever wondered how astronomers measure distances in the universe? It's a complex task, isn't it? Ponder this for a moment. The vastness of space, countless stars, galaxies, and celestial bodies, all seemingly out of reach. Yet we've devised a way to measure this unfathomable distance thanks to the pioneering work of a remarkable woman, Henrietta Leavitt. In the annals of science, Henrietta's name might not ring a bell as loudly as some, but her contributions to astronomy are nothing short of monumental. Working diligently at the Harvard College Observatory in the twilight years of the 19th century and the dawn of the 20th, Leavitt made a groundbreaking discovery that would forever alter our perception of the cosmos. She found a unique link, a relationship between the brightness of certain stars and their pulsation periods. This discovery became a cornerstone in mapping the universe's vast expanse. So, who exactly was Henrietta Leavitt, and how did she revolutionize astronomy? Born in 1868, Henrietta Swan Leavitt was a pioneer in ways more than one. Raised in Lancaster, Massachusetts, she was the daughter of a Congregational church minister, and her upbringing was steeped in a culture of intellectual curiosity and spiritual exploration. This setting would ignite her interest in the mysteries of the cosmos. Leavitt was a student at Oberlin College for 2 years before she moved on to the Society for Collegiate Instruction of Women, now known as Radcliffe College. It was here that she got her first taste of astronomy, a field that would become her lifelong passion. Interestingly, her introduction to astronomy was somewhat of a happy accident. She initially enrolled for an art course but switched to astronomy after being captivated by the celestial bodies. Despite facing personal adversities, Leavitt didn't let anything deter her from her path. In her early 20s, she lost most of her hearing, a misfortune that could have derailed many. But Henrietta was made of stronger stuff. She used this adversity as a stepping stone, focusing her energy even more onto her work. Post-graduation, Leavitt volunteered at the Harvard College Observatory. She started as a computer, a term used in those days for individuals performing mathematical calculations and cataloging data. Her role was to examine photographic plates to measure and catalog the brightness of stars. It was painstaking work, but Leavitt was undaunted. She had a purpose and an unquenchable thirst for knowledge. Her determination and passion were not unnoticed. Edward Charles Pickering, the observatory's director, recognized her potential and dedication. Despite the social constraints of the era that typically kept women in subordinate roles, Pickering gave Leavitt the opportunity to shine. With her determination and passion, Leavitt began her journey at the Harvard College Observatory. Little did she or anyone else know, her work would soon revolutionize our understanding of the universe. At the Harvard College Observatory, Leavitt found her calling among the stars. This hallowed institution became the canvas for her remarkable contribution to astronomy. As a member of a group of women known as computers, Leavitt spent countless nights analyzing photographic plates that captured the twinkling mysteries of the cosmos. These plates, imprinted with the light of far-off celestial bodies, held the secrets of the universe, waiting to be deciphered. Henrietta Leavitt's role was not merely to log data. She was tasked with the monumental job of meticulously documenting the brightness and position of stars. The work was painstaking, requiring an unwavering focus and a keen eye. Each plate was a puzzle, and Leavitt's job was to piece together the cosmic jigsaw star by star. Yet her journey was far from smooth. Leavitt found herself navigating the turbulent waters of a male-dominated field. She was a woman in a world that was not ready to accept her brilliance. Despite the societal norms of the time, Leavitt refused to be overshadowed. She pressed on, her determination unwavering, her passion for the stars undimmed. The challenges she faced were not merely external. Leavitt was hard of hearing, a condition that might have deterred others, but not her. She turned it into an asset, using it to further sharpen her focus and dedication to her work. Her disability did not define her, instead it fueled her resolve to make a difference in the world of astronomy. She worked tirelessly, her observations growing more precise, her understanding of the stars deepening. With each passing night, with each plate she analyzed, she moved one step closer to her groundbreaking discovery. She was on the cusp of unveiling a truth about the universe that would forever change the way we understand the cosmos. In the midst of these challenges, Leavitt made a discovery that would change the world of astronomy. Her story is not just about the stars she studied, but also about the indomitable spirit of a woman who refused to be limited by the constraints of her time. Henrietta Leavitt, a beacon of perseverance and intellect, forever illuminating the path for future astronomers. In 1908, Leavitt made a breakthrough by observing a particular type of stars known as Cepheid variables. These are unique stars that pulse or vary in brightness over regular intervals. Imagine them as cosmic lighthouses flashing their light across the cosmos. What Henrietta Leavitt noticed was that these Cepheids had a peculiar trait. The brighter ones took longer to go through their cycle of brightness than the dimmer ones. In other words, their brightness and their period, the time it takes for a cycle of brightening and dimming, were connected. This was a revelation, a key to unlock a new understanding of our universe. Leavitt painstakingly compiled and analyzed data on these stars, discovering what is now known as the period-luminosity relationship. The brilliance of this discovery was that it provided a way to measure distances in the cosmos. You see, if you know how bright a Cepheid variable truly is, and you observe how bright it appears from Earth, you can calculate how far away it is. It's a bit like knowing how bright a lighthouse is up close, and then figuring out how far away you are based on how dim it appears. This discovery was a monumental step forward, equivalent to us developing cosmic yardsticks. It allowed astronomers to leap beyond our Milky Way and measure the distances to far-off galaxies. This was the stepping stone that led to the realization that the universe was far larger than anyone had imagined. Henrietta Leavitt's work laid the groundwork for future astronomers like Edwin Hubble, who would later use her discovery to demonstrate that the universe is expanding. Yet, despite the magnitude of her discovery, Leavitt's work was largely overlooked during her lifetime, largely due to the gender biases of the time. This discovery, however, didn't receive the recognition it deserved during Leavitt's lifetime. But today, we acknowledge and celebrate Henrietta Leavitt's invaluable contributions to our understanding of the cosmos. Her legacy is a testament to the power of curiosity, determination, and the pursuit of knowledge, reminding us that sometimes, the stars we need to reach for are those that are pulsing, waiting to be discovered. Despite the lack of recognition, Leavitt's discovery had profound implications. Her research on the brightness of Cepheid variable stars served as a beacon, illuminating the path to deeper understanding of the universe's vastness. It was as if she handed us a cosmic ruler, enabling us to measure distances in the night sky with unprecedented precision. You see, the relationship Leavitt uncovered between the brightness period of Cepheid variable stars and their true brightness became a standard candle in the field of astronomy. This standard candle is like a universal yardstick, allowing astronomers to determine the distances to far-off galaxies. It was and continues to be a critical tool in measuring distances and understanding the spatial relationships between galaxies. Without Leavitt's discovery, our perception of the universe would be drastically different. Her work laid the foundation for the likes of Edwin Hubble, who expanded on her research to establish that the universe is continually expanding. Thus, not only did Leavitt help us understand how far away things are, but she also indirectly contributed to our understanding of the universe's very nature. But let's not forget the time when Leavitt made her monumental discovery. It was the early 20th century, a time when women were still fighting for their place in science. Despite her groundbreaking work, Leavitt was overlooked for the Nobel Prize due to gender-biased policies that permeated the scientific community. Yes, her nomination was a stride forward for women in science, but the denial of the award underscored the challenges faced by women in a predominantly male field. However, the ripples of Henrietta Leavitt's work have echoed through time, refusing to be silenced by the biases of her era. Her discovery is a fundamental tool in modern astronomy, a tool that continues to fuel our exploration of the cosmos. To this day, Leavitt's work remains a cornerstone in our understanding of the universe. So, next time you look up at the night sky, remember the woman who helped us understand its vastness. Henrietta Leavitt, a woman of remarkable intellect and diligence, brought us closer to the stars than we had ever been. Her work, though underappreciated during her time, has since become a cornerstone of modern astronomy. The relationship she discovered between the brightness period of Cepheid variable stars and their true brightness paved the way for measuring cosmic distances, effectively building a cosmic yardstick. This groundbreaking discovery, often referred to as a standard candle, has allowed us to grasp the enormity of the universe, bringing distant galaxies within our reach of understanding. In the grand tapestry of science, there are many unsung heroes whose contributions echo through time. Leavitt is one such hero, a beacon of light guiding us through the cosmos. Her story reminds us that progress often lies in the hands of those willing to look beyond the known horizon. Henrietta Leavitt, a true pioneer, whose legacy continues to shine as brightly as the